Hello and welcome to another exciting tutorial. This tutorial is on a project called as real-time traffic monitoring using YOLO. So this project is just an extension to the previous project which we did, that is object detection by using YOLO. So more than 80% of the code is similar, or rather the same code I am reusing here. So what is our objective here? Our objective here is in given a traffic video, we'll have a traffic video. In real time, you can replace the traffic video with the real time camera feed. Uh, so here, what we are going to do here, we are given a real time traffic video, and we are going to detect or count the number of vehicles in that video. Right. So let me show you that video here. So I hope you are able to see this video. This is the video. Right, it's a small video. We are going to count the vehicles and we are going to display that number here. Right. So we are going to put the bounding boxes around these vehicles. Right. Like this is a car. I'll put a bounding box here, 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 here. Right. And finally the count per frame. See, this video is made up of frames. Right. So this video is made up of frames. So we are going to count the vehicles in each frame, right? We are going to take a frame. We are going to process that frame. The process that frame means we are going to detect the number of vehicles in that frame and display the number for that particular frame here, the number of vehicles here, right? So this project can be really helpful for managing various traffic problems, right? Okay, so let us dive deep into the code. So this is the same code which we had seen earlier. I need, as we are going to use YOLO, and we are going to use the pre-trained YOLO. That means the YOLO model which is already trained on the COCO data set. Right? So that's why we will need this YOLO weights. Right? This file we'll download it. Then we'll need the configuration file, that means the architecture of this YOLO model, right? In fact, these two, YOLO 3 weights and YOLO 3 configuration, these two make up YOLO model or YOLO network, right? Because we have this is telling what are the various layers in this YOLO, and this is giving us the weights on which the YOLO is trained, right? So we are using those weights and the configuration file, and that is forming our pre-trained YOLO model, right? And this coco.names file contains the names of the objects on which this YOLO is trained, right? So this coco.names is a text file which will contain the names of the object. There are 80 objects, right? So let me execute this. So YOLO 3 dot weights is getting downloaded. It's a big file around 236 megabytes. So then another file, YOLO 3 dot configuration, is also downloaded. It's a small file. Coco.names is also downloaded, right? So we have these three files downloaded, and you can see here it's a Google Colab. You can see these three files here, right? Coco.names, YOLO 3 configuration, and YOLO 3 dot weights. Then I'll import the required libraries. I will import OpenCV. This is importing OpenCV. This is importing NumPy. NumPy is required because images are stored as the multidimensional arrays. Then we are for displaying the image, we'll need cv2_imshow. This is Google Colab specific. If you are using another Python environments like Jupyter, you will need cv2.imshow, right? So I'll need another library, that is files, right? So that files is used for doing the file related operations like uploading a file in Google Colab, downloading a file from Google Colab. For that purpose, I'll need these files. Right, then I'll so after importing these files, I'll load the YOLO model. So I will load the YOLO model. What is our YOLO model? The weights and the architecture, right? Weights and the configuration file. That's nothing but our YOLO model. So we are going to load it. Yeah, our see, this net is the name of our YOLO now, right? So we are loading this YOLO model by using this read net on this module DNN, right, of OpenCV. This DNN is module of OpenCV. On that we are calling this readnet function to load this YOLO file, right, YOLO files, and this is giving us a YOLO deep neural network, right, and that deep neural network we are calling as net. So net in short now is the name of our YOLO neural network or YOLO model, right? So and then we are going to get the names of the layers in that model. So get layer names will give us, we are calling get layer names on this net, our neural network, our YOLO model, we are calling get layer names. So this will give us the names of the layers in that YOLO model, right? What are the different layers, like convolutional layer, pooling layer, and other types of layer, right? So those all layer names are stored in this layer name. So layer names contains the layers of the names in the YOLO model. Okay. Now we are going to get the output layers, right? Because output layers are the layers which will perform the task of object detection, right? So we are going to get the output layers, names of the output layers, right? So how can we get that? By using this get unconnected output layers, right? Unconnected output layers, right? So this will give, we are calling this get unconnected output layers function on the our network. I'm sorry, right? So we are calling this. So this will give us the indices of the output layers. This will give us the indices of the output layers, right? Then with that index, right, we want names of the output layers, right? We want names of the output layers. So this is giving us indices, right? And we are iterating through those indices by using this for I, right? So for example, if the output layers are 3, 6 and 9, if the output layer index is written by this get you can unconnected output layers function are, let's say, 3, 6 and 9, right? So this will return a list of the output layer indices, right? So what I mean by that, I'll show you, right? Just a minute, I'll show you. So let's say this is what will be written by the that function, right? And now corresponding to this, I want the layer names, right? So for example, what is the name of the layer with index 3? Now if you see, this is what layer names looks like. Let's say, for example, this is just an example, right? Here you say this is index is 0, this index is 1, index is 2, index is 3, right? So the layer name corresponding to this is this one. Layer name corresponding to this is this one, let's say, right? So just I'm showing an example, right? That's how it works, right? So the list comprehension works like this, right? For I is equal to 3, layer names I minus 1, right? As why we are taking I minus 1? Because here the indices are starting from 1. Indices are starting from 1, right? So that's why we are, and now usually the indices in normal list starts with 0. That's why we are taking I minus 1, right? Okay. So because the indices are starting from 1. Okay. For example, when I is equal to 3, layer names of 2, right? That is layer names of 2, which is layer 3. So this is 2 because here it is starting from 0, 1, 2, right? Here it is starting from 1 actually. The output written by this, the indices start from 1, and here the indices start from 0. That's why this minus 1, right? So let's go back to the code. So here, and what we are storing in this output underscore layers, we are storing the names of the output layers, right? So this is returning as the indices. We are iterating through those indices, and while iterating, we are going to this layers underscore names array, and we are retrieving that particular name, right, with this index from here, right? Okay. So we have executed this. Now to upload this file, I just have to I need the video file now, right? The video file which I'll be processing, right? The video file which I'll be processing, that video file I need, right? So I'll upload from my local disk into this Google Colab by using this. If I run this, I'll get an option to choose a file, right? I'll choose a file. So let's say this is the file which I'll upload. So this is a small file, but will take significant time. So let's wait for this. So I'll pause the video till then just to cut the time. As you can see, the video is uploaded, right? So this video is uploaded in Google Colab, right? I'll be processing that video, right? And in real life scenarios, you can just replace this video with the real time video taken by the camera. Right? So after this, let's load this video into our program. So I'll execute this. So we have loaded this video, right? So the name of the video is traffic. So TRAFIC actually. It should be real spelling is TRAFFIC, but just this is name of the file, right? So by using video capture function of OpenCV, we are loading that video, and that video is called as cap now in our program, right? Let's check whether the video is uploaded properly or not by using if not cap.isOpen, right? So if the video is not open properly, we'll get this, we'll print this error. Yeah, the video is uploaded correct properly. Now this is the code, right? Which in this code, what we are going from this video, we are going to take one frame at a time, right? So and we are going to process that frame. What processing we are going to do in that particular frame? We are detecting the vehicles, and we are counting we are detecting the vehicles, locating those vehicles. That means we are putting the bounding boxes around those vehicles, and we are counting the number of vehicles and displaying that count in the video itself, right? That's what we are doing. And we are doing for we are doing this for entire video till the video is finished, right? So here is so we are calling we are initializing the width and height. So ret comma frame is equal to cap dot read. So what we are doing is we are reading the first frame from the video, right? We are reading the first frame from the video, right? So then we are setting the width, height, the dimensions. We are getting the dimensions like width and height by using this frame dot shape. We are getting the dimensions, width and height of this video, right? From the not the video but the frame, right? We are getting the frame, right? So what this ret is doing here, right? This ret is a boolean actually, right? If it will be true if the frame is read correctly, right? If the frame is read correct, we are reading a frame from this cap. What is the cap? What is cap? Cap is our video, right? Cap is our video. From that cap, we are reading a frame. We are reading a frame, right? So when the frame is read, when this frame is read in this variable called as frame, right? The frame is read in this variable called as frame, right? And this ret is just a boolean. It will be true if the frame is read correctly. This will be false if the frame is not read correctly. So then we are setting the height, width, and channels equal to frame dot shape. So we are just from this frame dot shape, we are getting the height of the frame, the width of the frame, and the channels. These are the color channels: red, green, and blue, right? So then we are resetting the video to the beginning, right, by doing cap dot set. So cap dot set will set the video to the beginning, right? So that means in fact this line will reset the video to its beginning. This property cv2 dot cap underscore prop underscore pos underscore frames, this is the property to specify the index of the frame to be captured next actually, right? By using this property we can specify the index of the frame to be captured, right? And now 0 means we are setting the index of the frame to the beginning, right? We are setting it to the beginning. Okay, so we are having the frames array. We are having the frames array. In this frames array, we'll be storing the frames which we are picking up from the video, which we are extracting from the video. In this array, we are storing those frames. Now, while this video, while this video is on, that means till the end of the video, right? While cap dot is open, that means while the video is not ended, not finished, right? We are going to do this. What we are going to do? We are going to retrieve a frame. Ret comma frame is equal to cap dot read, right? And so this was just to get the dimensions. We did this just to get the dimensions of the frame. I mean, that means what is the width of the frame, what is the height of the frame, and what are the channel. We just extracted one frame here. And we found out the dimensions, right? And then we reset the video to the beginning, right? And then we are now starting to process the entire video one frame at a time. So this while cap dot is open, that means while the video is open, video is not finished. So we are going to retrieve one frame, right? So this will retrieve the first frame, right? And then we are checking, is the frame open properly, is the frame read properly. That means if not read, that means if read is false. If read is false, we'll break, right? We'll break this while loop. That means the frame is not read properly. Then if the frame is read properly, we are going to detect that object, detect the objects in that particular frame, right? We are going to put the bounding boxes around that object, and we are going to count the number of vehicles in that particular frame, and we are going to display those, right? So this remaining code is exactly similar to the code which we saw for object detection using YOLO. Exactly similar. So I'm not going to go into great details about this code. If you want the details, I have explained line by line, each and every detail, minute detail I have explained in that video. You can go through that video. But I will just explain what each line is doing here, right? So we are again getting the height, width, and channels of the frame from here. Then we are detecting the object. So this is where we are preparing the input for our neural network, our YOLO model, right? So this our YOLO we are creating what is called as blob, right? By using the OpenCV's DNN modules blob from image function. So we are passing that frame which we had retrieved, right? This frame is like an image actually. This frame is like an image. It's an image actually, right? So we are passing that image to this blob from image function. We are telling the other parameters, like what should be the size, right? 416 by 416. This is the mean subtraction, right? So and this is the scaling factor, right? So this true means we have to convert the image from the image written by we want the image in the RGB format, but the image written by OpenCV will be in BGR format. So we want to swap that into, or convert that into RGB format, right? Crop is equal to false means do not crop the image further, right? So we prepared this blob, right? So this blob is now given as input to our neural network. Net is the name of our neural network. Net.set input blob. So we have given this as input to the neural network, right? Then we are having the next line, which is actually the forward pass in the neural network, right? So this line performs the forward pass through the network with the output layers, right? These output layers which we have got here, output layers, right? So this forward pass is performed through this performed with this specified output layers, right? So and then this will return this after performing this forward pass. We are getting the output, and that output we are storing in this variable called as outs. So outs is the variable storing the outputs produced by the output layers. Now how many output layers are this in this YOLO version 3 or YOLO v3? There are 3 output layers, right? So this outs will be storing 3 values. So now let me show you how this outs looks like. So this outs might look like this. This is the first value from here to here, right? So if I underline this, this is the first output, right? This is the second output. And if there are three output layers, we will have one more output. We'll have one more output here. I'll show you that also. Right. So by detection 1 by layer 3 now. This is layer 3. Detection 2 by layer 3, so on and so forth, right? Now what is this? What is this all, right? So if I enter here, right? So you can see here, yeah, you can see here. So this is how this outs might look like, right? So it's a two-dimensional array actually. Why it's a now what is this? This is the output produced by output layer number 1. This is the output produced by output layer number 2. This is the output produced by output layer number 3. Now you might wonder what this output is containing, right? And why there are three different layers, right? So so three different layers are for determining or detecting the objects of different scale, different sizes, right? For example, this layer number 1 might detect the objects which are very large. The layer number 2 might detect only the objects which are medium size. This layer 3 might detect objects which are only smaller size, right? So these are the various purposes of these various layers, right? So there are some objects detected here, there are some objects detected here as well as here, right? So these objects are detected by layer 1, right? So the first element of this outs itself is an array containing the objects detected by layer number 1. So that's why this is called a detection underscore layer 1. Detection 2 underscore layer 1. That means the second object detected by layer 1. So similarly here, first object detected by layer 2, so on and so forth. Now, in fact, now let's get inside this. Let's get inside this, right? Inside this detection 1 underscore layer 1 is a vector, right? It's a vector which looks like this, right? So this looks like this: 0.5, 0.4, 0.2, 0.3, 0.9, 0.1, so on and so forth. So now what are these values, right? So these values 0.5 and 0.4 are the center coordinates of the bounding boxes, right? So the object is detected, right? So the coordinates of that bounding box it is returning, right? Center coordinate, right? 0.5, 0.4, x and y coordinates. This 0.2 and 0.3 are the width and height. 0.2 and 0.3 are the width and height of the bounding box. We are going to put a box around that object, no? So these are the width and height. And this 0.9 is the confidence score. That means how confident this model is that this detected object is indeed an object and it's not background, part of background or some noise, right? And then the remaining values from here onwards, right? These are called as class probability. That means 0.1 indicates 0.1 is the probability that this detected object belonging to this particular class. If this particular class is car, that means 0.1 is the probability that this object is belonging to car, right? 0.05 is the probability that this particular object is belonging to class 2. If the class 2 is person, that means 0.05 is the probability that this object is belonging to person, so on and so forth. So this just I wanted to show you what this out contains. Just to summarize, this out contain in our particular case, this out will contain 3 elements, and each element itself is an array. That means I will, in order to process the outputs produced by output layer, I'll have to go inside this outs, right? One element at a time. That means layer 1's output I will process first, and inside layer 1 again I have to iterate through this array, right? I'll first pick up this, right? Process it, then pick the second, process it, so on and so forth, right? Once I did this, I'll go to next layer, so on and so forth, right? So for that I'll need the nested for loop, right? So these are the 3 arrays which I'll require the class IDs for storing the class IDs of the detected object, confidence score of the detected object, and bounding box coordinates of the detected object, right? So for out, so in out, so now we are we are going inside the outs, right? And this out will take for the first execution of this for loop, this out will take out will be this array, out will be this array. Now out is this array. Now inside this array we are going, right? We are going inside the array, right? And inside this array, the first value, this first value, we are calling it as detection, right? So this detection will take, this value, this particular value in the first pass of this for loop, right? Then we are taking the scores of the scores means class probabilities. See why detection of 5 onwards, right? 5 onwards means here onwards. So this is 0, 1, 2, 3, 4, and this is 5 onwards. So 5 onwards are the class probabilities. So we'll get those class probabilities. We are taking a slice from there, right? And we are calling it as scores, right? Then class IDs. Now out of those scores, so these are the class probabilities, right? So which class this particular object will belong to? Definitely with the maximum probability, right? So we'll find the maximum probability, right? Maximum score, and we'll note that maximum score, we'll note that, and that will be the class ID. That will be the class ID. Then we'll get the confidence score from scores array. Again, from scores array, we'll get the score for that particular class ID. So what we are doing here, we are finding the scores. Then we are finding the what is the maximum score. What is the maximum score? And that maximum score will be our class ID, right? And again, we are going in we are going in the scores array. From that, we are getting the scores for that particular class ID, right? So we are doing all of this here. I have explained in detail in the session or in the video on the object detection using YOLO. You can go through this for if you want more detailed description or explanation. And now if the confidence is greater than 0.5 and the class ID is 2, right? So the class ID for cars is 2, right? That means if the confidence is more and the class ID is 2, we are going to process that object, right? So what we are going to do, we are going to find the center coordinates, right? So center coordinates are already given to us, right? So center coordinates, center underscore x, center underscore y. So we are going to get the center coordinates. Then we are going to get the width and height, right? W and h is equal to int into detection 2 into width, right? So we are going to multiply detection 2. What is detection? So we are going to get the so what this detection 0, detection 1, right? If you see detection 0, detection 1, this will give us detection 0 will give this 0.5, detection 1 will give this 0.4, detection 2 will give this 0.2, right? And these are the center coordinates. These are the width and height, right? Width and height, and this is the confidence score, right? So that's what we are getting here, and we are computing the center coordinate. We are computing the width and height here, right? So then we are computing the top left corner x and y coordinate, right? Top left corner x and y coordinate we are computing. Once we know those coordinates, we can draw the bounding box, right? So to the bounding to the boxes array, what we are appending? We are appending the top left corner x and y coordinates and width and height. So once we know that we can simply put the bounding box, right? Because I know the top left corner, I know the width and height, I can just draw the bounding box. Then we are appending to the confidence array, we are appending the confidence score of this, right? Then the class IDs, to the class IDs, we are appending the class ID which we have got, right? And then we are performing what is called as suppression, non-max suppression. In this, what we are doing, we are just neglecting or we are eliminating the redundant boxes which are overlapping, right, by using this NMS boxes, right? So from here only non-overlapping boxes we are making sure that only non-overlapping boxes are considered, right? Then for I in the range length of boxes, we are plotting with these boxes, we are plotting the rectangles around the objects inside the frame. Around the objects inside the frame, we are plotting the rectangle. This piece of code is just plotting the rectangles, right? Then we are counting the number of vehicles, right? Number of vehicles is nothing but length of indices, right? Length of these indices. What are the indices? Indices are nothing but the number of frames, right? Number of not frames, number of boxes. Number of boxes, we are just counting the number of boxes, right? Number of boxes is equal to number of objects detected, right? So that is our vehicle count, and we are going to put that vehicle count inside the frame, right? By using this this font and this color actually here, right? And then we are appending that frame, modified frame or process frame to our frames array, right? So this is our frames array here, right? So the first frame is processed, right? So likewise, again we'll enter into the for loop. We'll take the second frame and process this code again with the second frame. We'll repeat this code again, right? So this code will be repeated till the video is not finished, or till there are more frames, right? And then after doing that, we'll release all the resources held by this cap, right? So we'll say cap dot release, right? So this is here, cap dot release will release the video capture object after processing all the frames, right? Then we are saving the frames to the video, right? So you have here these two lines. So these two lines are used to this here we are setting up this video writer object. To write the processed frames into the video file, right? So video writer, this is the video file in which we are writing the processed video, right? So this is the video file in which we are writing the processed video frames, right? So we are mentioning this is in fact 20 is in fact the frames per second. 20 is the frames per second. And then we have this width and height is this is the size of the frames, right? And this force is the object we created here, right? Okay, so here basically what we are doing is we are writing the frames which are processed to this output video file, right? Then we are setting up this object actually, right? So then we are writing to the frames, right? So this for loop, in fact, this for loop writes each frame in the frames, each frame in the frames to the to the output video file. So this out is the output video file, right? Then we are releasing the object video file. Video writer object, right? In fact, out dot release, we are closing the video writer object and releasing the output video file. So then we are downloading the processed video file, right? So files dot download output dot mp4. So this file will be downloaded into in our local disk by using with the name of output dot mp4. So that's the code. I hurried through the code because it's already covered in YOLO object detection. So if you want detailed description, you can always go back to that video, right? So just I stressed upon the new part, which is the part of the code which is new here, right? So let's execute this code, right? You see this code is running. You see this one. Now our code is here, right? This part of the code is running, and this part of the code is running, right? That's why this arrow you can see here, right? Okay, it will take some time. So I'll just pause the video just to cut short the video length. As you can see, the processing is complete, and we are downloading this file output.mp4, right? The file is getting downloaded. Our process video is stored in output.mp4, and we are downloading this output.mp4, So again, just to cut the time, I'll pause the video again. As you can see, the video is almost is about to download, right? It's just finishing the downloading the video. Yeah, it's finished, and you can see here, this video is downloaded, right? Just a moment. So not this one, this output, right? So output 1, because output I already downloaded the first. I had executed this earlier. So this is the new video downloader. So let's just run this, right? So you see this is the bounding boxes put around this vehicle. You can see, right? So you see the vehicle count you are not able to see here. The vehicles, you see the vehicles left corner, you can see the here you see this vehicle count, vehicles 19. There are 19 vehicles here, you can see, right? 19 vehicles. So that's what we are displaying, right? Let me run this one more time. This is the output, right? You see vehicle count, how this vehicle count is changing in the left corner, right? In each frame we are counting the number of vehicles, right? So let me run one more time, right? Here 19, 20, 21, right? So in each frame we are counting the number of vehicles. So that's the real-time traffic monitoring project. Now only thing is here what we did, we took the video as input, right? Now if you are putting this system in place, you have to use the camera, take the real-time video of the traffic and feed that video to the system, and then this system will tell will help you to monitor the traffic. So I hope you enjoyed this project. Thank you so much for watching. Thank you.